And good evening, good afternoon, good morning, everybody. Welcome back into the Dragon's Den. Hey, Mr. Wizix, Liz, how's it going? Hope you guys are having a good day today. I'm kind of feeling weird because I'm over this way versus over that way where I'm normally at, but I moved the printer all the way to the right, partly because I can't see around it and I can't see through it because it's got this ACM back panel. If it was clear, I could possibly look through it and see both screens, but I'm having to kind of sit down here at a moment so I can see the screens and stuff. It's weird. But regardless, we've got the printer up here. We're going to be doing some movement and some commissioning stuff today. So, yeah, let's be prepared. Hey, how's it going, Sebastians? Welcome in. Or Slab Stations, welcome in. Um, so yeah, um, let's see what's going on with the printer. Let me switch to the bench side camera here. I'll be able to say hi everybody again. So the printer is up. I did power it on, and surprise, surprise, no shocks, no nothing. I did finally get one of the power inlets in that will allow me to screw it in yesterday, so I did that. The standard 10 amp, which should be fine because I'm looking at this, it's an LRS 200 power supply. On the 300 size, a 10 amp works, right? If you're going to a 400 or 500 size, especially in 110, so US and Canada, you've got to go to a 15 amp rated outlet, and I had two of those that just came in right before stream, so I may think about swapping those out later on. We'll see. Let's see, a couple of other things you might be able to tell. Let me pop this up some. Is I have gone ahead and put our foam tape around all the edges, and I have tried getting one of the panels on. So I had the side panel on for a while. I did just take it back off because you'll notice that we still haven't belted these Y motors here. And we're not going to belt these Y motors just yet. Okay, come on, work with me. Here we go. We're not going to belt these yet. What's going to happen through the commissioning guide is we verified the movement, or at least I've verified that it moves in the right directions. We're going to run through some things on the commissioning guide, which is going to include the build plate prep. That's kind of where we're at right now. We're going to do a bed mesh to validate that our frame is not skewed. Okay, it's not twisted and it's not skewed. So we're going to do that first. Then we'll shut things down. We'll take the build platform off. We'll install the magnet and the heating bed, and we'll get that wired up. And then we'll come back and start going through some other things, and that will include PID tuning both the bed and the hot end. We'll do a Z offset with the beacon. We'll work on belt tensions. Now this is interesting. We'll work on belt tension for the XY, for the core XY system first. Okay, and we'll get those properly tensioned. Then we'll do the Y belts. And after we get our Y belts done, then we can go ahead and do input shaping. Okay, and skew calibration and all that good stuff. Hey, Jana, welcome in. Think I will get to install beacon contact tonight. Beacon's installed. So I'll walk through a couple of things with you guys here in just a second here. So let me switch my view. I have to, yeah, of course. Why would it be on the one that I wanted? Give me 1 second here. Change the focus. Okay, as you can see, we're up and running. And by the way, welcome on in, Big Jano. Welcome on in. I'm really weird. So the printer's all the way on the right side of the bench. I'm at the far end of the bench. So you're seeing me from the side looking through the printer. Feels kind of weird. Um, so as you can see, our Rat OS was up, or it's up, meaning it's talking to all of the MCUs, right? What MCUs do we have? Well, if I come over here to the machine tab, you'll see we have an MCU, which is the STEM32F446. That's the Octopus board. You'll see an MCU for the Beacon. You'll see the MCU for the Raspberry Pi. We're going to need that to do some of the macros and stuff. And then we have the tool board itself, which is the EBB42 up here. So with all of that going on, I was taking an error when I first brought it up. And what that error was the Beacon board. Remember when we did everything on the bench, we had the Raspberry Pi up with RatOS. We got the Big Tree Tech Octopus firmware flashed. And then we had the printer down here on the ground. We ran a big long cable and we flashed the EBB42. What we didn't do is connect up the beacon for the beacon to get flashed. So it was taking an error because the beacon wasn't up to date. And in reading some of the online information, it says do not run the beacon install scripts directly. If you do that, the software goes into a location that RatOS is not expecting it to, and you'll have two competing installs of Beacon, right? So how we got around that is we come into the configurator tab here, and we click on Help. And under here, you have the ability to flash the connected boards or flash the Beacon firmware. So I click Flash Beacon Firmware, and the firmware had already been downloaded by the Pi. It just flashed the Beacon board. We did a reboot and everything came up. Okay, so we were good there. Then, back out here. There we go. Then we came in here and did a couple of the next steps on the RatOS configuration, which is verifying the stepper directions. Basically, you get the tool head about in the middle of the plate. You run that command set underscore center underscore chromatic underscore position. When you do that, you're basically telling it, I've been manually centered, assume you're in the center. Okay, and then it allows you to move your tool head around without doing a homing sequence, right? So then you tell it to go X to the right, X to the left, and you're making sure that your X and Y are moving in the right direction, which it is, and the Z is moving in the right direction, which it is. So that movement is verified already. Verify the end stops. That's pretty easy to do. We come over here to our RatOS. We can do the query end stop command, or I normally like to just come down here to the machine. And you click on this refresh and it'll tell you what's open and what's triggered. Okay. So if I manually trigger the X end stop, which is on the tool head, and refresh, it's going to tell me X is triggered. Okay. If I manually trigger the Y end stop and run that command, now X is open, Y is triggered. I'll run it again. Beacon is, or end stop Z is saying it's triggered. I'm not sure because we haven't done an initial calibration on Beacon. I'm trying to remember back to when I did Beacon on the K3, if it stays in a triggered state or not. But that's basically where we're going to start today. Hey, Shrimp Father, how's it going? You got your coffee? There you go. I got my Dunkin' here and a cup and a half of Yeti mugs, so I'm good for a bit. So yeah, basically where it tells you to start off here is, okay, now go and do your Z offset. This is assuming the PID probe that's on like a RatRig 3.1, not necessarily a beacon probe, because you're not going to do a probe calibrate with beacon. And then it tells you to get into your tuning and stuff. So that's where we're going to leave this documentation and come back over the commissioning guide. So if you remember from the last stream on the commissioning guide, we came in and we made sure that we had the firmware. So we did that. We got the firmware. The slicer, we went ahead and configured Orca slicer for a RatRig V4 or VCore 4 with both a 4 and a 6mm nozzle. Now I have a 6mm hardened nozzle in here. So that's what we'll be using in our config, is the 6mm nozzle. The add your machine, I will do that. We'll add in the IP address so we can send files directly to the machine. And now we get into initial calibration. So here we're going to prepare the VCore 4 for printing before the machine melts any filament. Specific steps must be followed. If they're not followed, different kinds of problems will appear and troubleshooting becomes more challenging, right? So that's kind of where we're at. Build plate prep. So before we start tuning a machine, please perform a bed mesh to ensure your build plate is ready to print. The bed heater should not have been installed at this point. You do not want the bed heater installed. You do not want the mag surface installed. We're using just a bare plate. Okay, it looks like they have their surface on top. They're probably taking pictures and doing this with a, that looks like a CAD rendering actually. So what I did off stream was I moved the tool head here to all 3 locations. And I just brought the bed up slowly. And quite honestly, I used, what did I use? I used a print that I still had sitting here on the side of the bench as a spacer. So I wasn't trying to get it to touch the bed specifically. I was trying to do a spacer, a known amount at all 3 points. So there's a tiny bit of a gap there. Okay. But what that did was it brought the bed into a somewhat approximation of level to the tool head. Okay. And that's going to be our starting point. So proceed to manually adjust the lead screws. It doesn't need to be perfect. The machine will perfect it later. We just want to get it close so it's not having to try and do a major adjustment. Okay. And now after ensuring the bed is mostly level, we're going to run the following command. And this is the initial calibration for beacon. So the machine will home all axes and prepare the beacon. It will home your printer, run the calibration fully automated. The command can throw a tolerance error. In that case, just keep repeating it until it passes. So what we're going to do is we're going to copy this command and we'll put that into our console and rerun it. So for safety and peace of mind, the LED will turn on as soon as the contact system determines it has a strong enough signal for detection. It should normally be, it will normally turn on up to 10 millimeters in advance of a metal target, allowing enough time to manually end stop the machine if necessary. So I'm still not sure if beacon is working right at this point or if it's going to work right after this calibration. So when we tell it to do its thing, it should drop the bed down and home X and then Z. X then Y, and then come back in to do Z. And as soon as I hit go here, I'm going to move up here to the emergency stop and be ready to do an emergency stop if needed. Sound good? Let me know who's ready to see this thing move on its own for the first time. And hopefully we don't, I don't know, do a bed crash and break anything. Send it. All right, Shrimp Father, we'll do that. So the bed dropped a bit. It comes forward. X comes over. And it's going to start doing Y. I do have a light on for beacon. And how about that? Boom. Beacon calibration finished. Beacon calibrated at 150, 127.5 from 0.2 to 5. Speed 1 millimeter. Temp was regular, so we didn't heat anything up. And now we need to save that config. It does tell us to save the config at the end. Yeah, once you're happy with the achieved resistance, click accept on the console, then type save config. Now I'll go ahead and do the restart. And just like that, we have beacon contact. So how sweet is that? Uh-oh, Big Jano. We'll have to circle back about your XL issues. Yeah, because I'm curious to hear what XL issues you're having. Okay, so RatOS has restarted, and we should be good now. Build plate preparation. Now you may perform a Z-tilt calibration. This can be found on the dashboard page. So for giggles, I never do a Z-tilt. In fact, it may not let us until we home. Let me just see. Yeah, it's going to give you an error if you do Z-tilt directly without doing a home first. Let's do a home all. Okay. Now we're going to go ahead and do a Z-tilt. And it's going to go to all three corners and try and get all three corners to match the same height as the center. So, and once again, I think we're doing this. Yeah, we're doing that with contact. Leave. No, it's not. So it's not doing that with contact. So Z-tilt, it was actually doing it with the eddy sensor, and you can see that we are at 0.003608 difference between those 3 points. Not bad. And then I'll home again. Okay, so we did a home, and now what we're going to do is we're going to do a bed mesh. So we're going to come over here to the height map section. And normally, if you just click calibrate and you haven't homed, it's going to tell you to home. So you would have to hit home, but we just did that. So we're going to say calibrate. Hey, Techno Slide, how's it going? Yes, the RatRig is alive. I repeat, the RatRig is alive. And I'm going to change this to baseline just because. And it's doing the bed mesh using Beacon in its normal state. Oh, Techno Slide, this isn't that bad. When I was building the Annex Engineering K3, which is a 180 by 180, we did it at what, 20,000 acceleration. I think it was 20,000 acceleration, 10,000 millimeters a second, 100 by 100 points. It was crazy, and it was just like so. Okay, so it tells us next to, now that we have that mesh, we want to click the scale gradient and move the Z to max. So we'll click scale gradient over here in the bottom left. Then we're going to grab this scale Z max all the way over. Okay. Now, in our baseline mesh here, it did a 20 by 20, and our range was 0.223 millimeters. So pretty good. Not flat, but pretty good. And we'll see, whoops, darn it. There we go. Okay, so X is here, Y is here. So it looks like we kind of crown over along the X axis. The Y axis, we're kind of dipping back a little bit. Not major, right? If your bed is not flat and appears to be tilted or twisted, similar to the image below, not that bad, you will need to verify the alignment and squareness of your frame. And check the following tutorial video on how to properly identify squareness issues in your frame from your height map mesh and correct them. Basically, and what I was looking at this is, we will be able to adjust our frame members to take out some of that taco or that bow. Hey, Maker Viking, how are you, my friend? The image below illustrates a bed mesh with a twist. Twisted meshes are a symptom of a non-squared frame. You will observe a peak or a depression on point C or D. Okay. The blue arrow points to a peak in height. To correct this, we need to adjust point C. Just unscrew the highlighted quick connect, gently tap the extrusion on the bottom, and retighten. So very small corrections, right? So this was low, this was high. At higher, not. Okay, they must be looking at the reverse of what I am, because the blue is lower and the red up here is higher value. Anyhow, I mean, quite honestly, 0.223 is not bad. Front's higher, back's lower. So what I can do is I'm going to adjust the rear just slightly. I need the things for my quick connects, which is the other one. So what we're going to do here is I'm just going to undo this slightly. Not a lot. And give it a gentle tap. And then tighten it back up. I'm going to do the same thing on the other side. And we'll see if that changes our bed mesh. Like I said, I'm not trying to really kill anything here. I just want to try and see about that. Oh yeah. Yeah, and it's actually not doing contact. It's just doing standard beacon. All right, so calibrate. We're going to call this, what are we going to call this? Change one. Oh yeah, and quite honestly, 0.223 on a 300 bed, that's easily covered by a bed mesh. So this is just trying to fine tune for perfection. So now we're at 231, so we actually got a little bit worse, right? We actually got a little bit worse. So it looks like the rear corners dropped down a little bit more. You know what? I think I really do need to knock it in the other direction based on what I just saw there. So now, mind you, I'm hitting the right side quick connects. There's also that back frame quick connect that I can't move at all that this plate's adjusted to. So, or attached to. So and we did our best to square up this frame as we were building it using our 1, 2, 3 blocks. So, well, let me recalibrate from, hopefully so. Yep, yep, and that's what we did, slab stations. So if at first it doesn't succeed, beat it into submission again. So change 2, we're down to 211, so that was a little bit better. Now I don't think we can knock these fronts up because of the front frame piece here. So well, and I guess too, if I need to, the back panel does have an access hole for those quick connects. So if I feel like I need to make a little bit bigger adjustment, I can loosen those as well when I do the smacks. But I like how quick and easy this is to actually get this to work. I mean, not work, to get it to probe. I mean, it probes a lot faster. If we were doing like a BL touch or something like that, it normally is a lot slower. And this is doing a 20 by 20 grid. Yeah, now we're down to 176. So not bad. Not bad. So we'll try that now. I'm gonna loosen the side and this rear just a bit. We'll try and do this one more time. I mean, 0.176 is perfectly good for me. I'm never going to get it 100% perfect. So one last one here. And yeah, this is triple Z. So we've got triple Z. We've got the Core XY belts are on right now. Once we're done with a couple more steps, it'll tell us to go and belt the Ys. The dedicated Y motors up here for the hybrid system. And then, all right, we're at 0.149. I mean, I don't know how much more I want to try and play with that. I do think that I want to home and do another Z tilt. Hey, for Heathen, actually, this is a 300 by 300, and I am so glad I did a 300 by 300 because it's barely fitting on my counter here. If I had gone to the 500, it would not fit on my workbench. It would be sitting on the frame and the motors at this point. Okay, so we're shooting for a tolerance between the 3 points of 0.02, and we got 0.006023. So Yeah, so the RatRig, this is the 300 by 300. They do a 300, a 400, and a 500 in these machines. So it's stupid crazy. And we haven't made any more adjustments yet. Darn it. That is so sensitive. We haven't made any more adjustments to this just yet. I'm going to go ahead and do a calibrate. We're going to do one more time. The S8 is 310, so you know, love them big beds. Oh yeah. Well, and here's the thing is I've got the Ender 5 Plus downstairs, which is 370 by 370. I have a Trident 350 downstairs. Those are my big machines. Now I got this in a 300 size, and they came out with the V-Chonk, and I was like, ooh, I really like the V-Chonk. Well, the problem with the V-Chonk is, the V-Chonk, God, why is words not coming to me? The top plate and the bottom plate are monolithic, and you need a 400 size bed to do it. So it's like crazy. I've got a bolter printed, I just haven't assembled it. Stop. Okay, so you'll like this for heathen. So we're 0.2 off. So I'm just loosening up the quick connects on the frame here. We'll run a calibrate again. You need a shoemaker's handle. Well, I mean, it works. It's a rubberized handle, so it's not like I'm going to mar anything up. But regardless, this is going to be the last one. If we're at 0.2 or less, this bed mesh will square whatever needs to be squared for this printer. I'm not looking for perfection on this. So we knocked it down and we got into a 0.184. So not bad. Not bad at all. We got down to 0.149, but we're good. I'm going to call that good, right? Generate another mesh to ensure the frame alignment is 100% square. Then you can proceed to the next step. If not, take your time, analyze your frame carefully before moving on to the next step. So looking at this head on, it does kind of show some type of little bow there. Right, so this is looking at it from the right side. This is looking at it from the front. There's a tiny smidge of a bow. And I don't know how much I want to beat this into submission. Well, yeah, once again, it's got a bow, and it hasn't been heated up at all yet. Oh yeah, that's why I gave them different names. is so I can see the different ways that they move, because I can pull those up just by clicking on them. Let's see, this one we were doing good, and then it kind of dropped back down again. So I don't know, Free Heathen. We don't even have the heated bed on this yet. It literally doesn't. Oh yeah. Oh yeah, most definitely. What we're doing right now is we're using this bed mesh to verify that the frame itself is squared. Okay, if that makes sense. So our peak is in the back, but my only way of adjusting is at the back. I'm not going to be able to adjust these fronts because of these front struts. There's just no way I'm going to, I've got like, I don't know, 1/4 of an inch to play with. So if I can smack this all day, it ain't going to adjust it up here. So I'm adjusting in the back. Yeah. Yeah, we're just trying to make sure that our frame itself is square. Okay. And quite honestly, I don't know if we're gonna get it down. Let me see if this.
Hi YouTube, welcome to a video on my channel 3D printers and a whiteboard. Today
Holy crap,
we will be doing
27
something
minutes?
printer specific. We will be looking at the VCore 3 made by RatRig and its bed leveling and frame squareness. The printer gets that used to be a flat bed before I did that. The printer gets shipped with one of those beds usually, which is a cast aluminium bed to the middle. So bowing to the middle means that your gantry is bowed in this direction. So we have bowing here and bowing here, and this is one of my, if I'm not mistaken, I think that's
yeah. I'll have to watch this. Whoops. I'll have to watch this off
from the VCore 3 series.
Off stream, and see if there's some things I can do to straighten this out even more. But for now, we're going to keep moving on. It says to shut the printer down, and we'll now take the bed off. So in order to make it easier for me to get the bed off, I'm going to move the bed down some. Making sure that moves in the direction I want it to. Okay. Now I'll turn the system off. Yeah, so as of right now, the heating element and the magnet are not installed on this, and that's what we're getting ready to do now. So I'll reach around here and find my switch, maybe. There we go. Switch done. Now the bed is just going to be able to pop up out of its mount point. So you just raise that up, and do the one in the back here. And now we can remove the build plate. And as mentioned before, it starts off telling us to put on the heater first. I'm not going to do that because you'll put the, well, I guess we can since we've got the balls on here. We're not going to be pressing down on the top and messing with the heater. But I always do the magnet first and then come back in and do the heating element. Because normally you don't have the standoffs already on it. And I'm going to clean this down because I've gotten fingerprints all over it. We're just using some IPA. We'll need our, here's our bed heater. Also need our magnet. So what I like to do is kind of just set my magnet on there and figure out where I'm going to be at and where I place things. That kind of works using these little M4 pins that we put in place as a backstop. That will help me align and keep a straight edge at the front of the bed. Let me see if I can't bring you guys around here. It doesn't show you anything, does it? Put you there. Yeah, so by setting the magnet down and going up against these little 4mm shoulder pins that we put back here, it will make it easy and keep everything nice and lined and get a good border around the edge. Hey, Miss Lee Marie, how are you doing? Hope you're doing well. So what we're going to do is we're just going to peel back some of our paper to expose the magnet. Set it back down there. And before we press anything down, we want to make sure that we get our good alignment again, side to side, front to back. Then we can come in gently, just press the edge on. Start working our way forward. So Miss Lee Marie, how goes the V02 build with your sister-in-law, one of them? I haven't been able to watch because you guys start up at noon and I'm normally streaming on Saturday from 10 on. And I have a tendency to run long on Saturdays, so. And there we go. One magnet installed. And flip that over right on top of that magnet now. We'll clean the back. Yeah, the V0 is, I'll say, probably one of the most difficult Voron builds, simply because of its size. The 1515 is kind of a pain in the tuchus to work on. And yeah, if you forget to put a nut in, it's even worse. Not so much now with the like the, I guess the roll in or drop in ones that LDO makes. But yeah, it's a bit of a pain, to be sure. Okay, so now that we've got this on, what did I do with the heater here in front of me? So remember, where the two balls are is the front, where the single ball is, can't see because of the thing there, that off. Where the single ball is back here is the back. So this is the front edge. This is the back edge. This is where your your ground wire is going to go. So we want to orientate our our heater where the wires are coming out the back side. And what we're going to be looking to do is just get this laid out and pretty much centered. And I like how they did this kicked off to the side. That helps. Yeah, that's going to look good. So I'm going to go ahead and remove about an inch of this. Just peel it back down on itself, or I guess probably about 2 inches. Peel it back down on itself, and don't try and really crank that down because it's going to provide a little bit of a spring there, and that will allow you to be able to line up your either your magnet or your heater on your build plate. What I'm finding is we've got these little shoulder bolts here that we're using as end stops for the build plate. So I'm trying to get those lined up side to side on those. And then front to back about right. And then I can come in here at the front edge and just push the front edge down. And once we get that started, lift this up and we'll pull our sheet back some more. And I tend to work from the center out in both directions. And that'll make sure I don't get any air bubbles in here. I know there's some people that come in with like the big roll, or not the big, but like the little rollers like you would use for doing some tile work and stuff. I don't use the roller. I don't own one, so. And be careful. So the one where your red wires are coming into, this is your thermistor, and that is a glass bead thermistor. If you push directly down on top of that, you could shatter that glass bead and then your thermistor is bad, which means you just put this on and now you're going to have to peel this whole thing off and go get a new heater. So be very careful, go around the edge of it, right? But don't go directly on it with any pressure. That's why I like to put the magnet on first, then put this on, because there's no chance of me flipping this over, then pushing on the magnet to get the magnet on and breaking that glass bead. Now, if this were an edge-to-edge heater, you would, of course, just put this on and be done with it. With this having a pretty good gap around the edge, what you can do, and I've done this on a couple of my machines, is what I would suggest is put an edge of tape around and then come back in with some RTV, some high temp RTV, and overlap the edge like that with RTV, which is a heat resistant silicone that you would use to make like gasket material for engines. And RTV stands for room temperature vulcanization. It is basically like a rubberized silicone, and it will also make sure that this heat bed or the heater does not come off of your build plate. Okay. Oh yeah, Liz likes to turn me on and listen to me do my build as she's doing her housework. Oh yeah, definitely. Okay, so we're going to come back here and take a look at the guide. And the guide, of course, tells us to do the heating pad first. Fully attached, no trapped air bubbles. Yep. Using the same method, apply the magnet on the other side of the surface. Yep. Install the print surface. The flex plate surface may retain impurities. Blah, blah, blah. Dirty build plate. Clean your build plates. Yep. Bed wiring. This is really why we had to shut the printer off, is because we're going to have to do the bed wiring. So we've got the main wires here for the heated bed, and we're also going to need to do the ground wire. We're probably going to have to change up some of the wire ends for the heater itself. So let me grab, because I want to install the ground here before I do anything else. So let me grab my crimper. Now, at a minimum, you want to use a fork connector, but would be even better for attaching your ground wire to your bed would be to use an eyelet connector. So you can use a fork connector, right? The fork connector. This type of connector would be even better, right? You got your straight eyelet connector there. That would be even better because it's not going to stand a chance of coming off. The screw would have to come out completely for that eyelet to come out. So okay, so I pulled that out. Our ground wire, they do provide a long ground wire here with 2 fork connectors. I'm going to use one of the fork connectors. The other one is going to be, like I said, I'm going to use this round connector. Okay. Looks like 20 gauge wire. Yes, it is. It's ground, so we should be perfectly fine. I'm hoping to be able to use the round connector because I just think it provides a better secure connection. It may be that if it doesn't, that you have to use a fork connector just because you don't have the right size round connector. But I'm going to go ahead and just kick this over at an angle so that I can bring that ground wire back down in the same spot with all the others. Out there, I'm going to bring you all back out here. Because what's going to happen is we're going to set this up in the printer. Come on. Just like that, our bed's back in there. We're going to take our wires and we're going to have, I can grab all of the wires in one shot. That would be great. There we go. We need to feed these through to the back. There would be our ground wire. Ground wire, the bed heater wires. What is going on here? Try and get things not all twisted up on themselves. Two heater wires and the thermistor wire. Here we go. So interestingly enough, there's no strain relief provision for this at the bed, and there's no sleeving called out for this. Now there is sleeving called out for the tool head. There's sleeving called out for the PTFE tube, but no sleeving that I saw for these wires, which I think is a little strange. Not going to lie about that. The other thing that we're going to need to do is do the connections on the back of the printer. And I'm trying to think how best to do that. And how best to do that, maybe just not to show you guys because I don't have a very good angle to do it in. That away. So bed cabling wise, we come over to the AC wiring, understand the risks. We're going to have one line that comes to our solid state relay. And then from the solid state relay up to the the power supply, and then another one that's going to come from the bed and go directly into the power supply, and the ground goes directly to the power supply. So once again, all roads right here lead to the power supply. So we grab my connectors and my crimpers and stuff. I think I'll try and spin it. I'll try and spin it. Give me 1 second here. Kind of a pain because, like I said, it's really a little bit too big for my counter here. But I can't really get a bigger work table in here either. Okay. See, this is where we're at, is we're literally like a quarter of the connector, or a quarter of the foot is what we're sitting on. Okay, make sure you unplug your main power, which is what I just did. You don't want your main power. So there's a couple of things that are going on here. One, there's no cable provision for cable sleeving. Two, there's no inline ceramic fuse called out or installed. So that would be something that I would need to do. I think I probably still want to do that. So we will most likely do that. I'm going to bring this wire directly up and get it through our cable system here. Oh, and I forgot, there is strain relief right on the side of the rear bed mount. There is strain relief. And I am going to use some of their split loom because it'll, that is definitely not going to work for these wires. That is PTFE tube and only the PTFE tube. I will take some of the thicker split loom here because I don't think I'm going to need all of it anyhow. And we'll use some of it for the tool head, and the rest will come for the bed wires here. So let me try and get this on there. I just want to make sure that we have proper strain relief and stuff in here. And I'll go ahead and add one of the ceramic fuses. I'm not sure where I know I have them. I just need to go find one, like in one of 3 places. And I will do that off stream and just add a ceramic fuse in line. And you want that fuse in line with the connection to the SSR, not the connection back to the back to your PSU, because the connection back to the PSU would be the connection back to the PSU would be the neutral connection. So whichever one you make these go to here, just kind of do the push pull and say, okay, that's the one I want to use. This is going to go up and around. Open our cable chain back up. Add this wire in. And it says to come across and go up. We're going to place it right there. I think I may come up and go over. And we've got plenty of room here. So I think I'm just going to take it straight up and around the top. I'm just going to take a couple of these off at a time. Hey, thanks for the follow, Reverend 64. How are you doing today? Hey, Kegel, welcome in. Should I use nylon on the screw going end to prevent corrosion? No, because you're using that screw to also provide the ground. So it's providing the hold down, but it's also ensuring a better ground rather than just the compression of the ring terminal to the and really the fear there would be, of course, galvanic corrosion with the similar metals. And I've never had an issue with the steel screw and the oh good gracious, come on. Yeah, I've never had an issue with one of those, so kind of where I'm at on it. You were cooking and watching Z and Z. There you go. Okay. Bring this up, kind of around behind that. And once again, I need to work on the cable management over here a little bit more. Is that in the bottom or the, I think it, I can't remember which one it was in. Bottom or the second one? I guess we'll find out soon enough. We'll plug this in, and if it barks that it doesn't have, it takes an ADC out of range error, then we know we need to put that in, the different plug. Once again, we do have a zip tie spot right here. We just kind of bring these around, get them lined up there. And yes, some of these are still long. I'm fine with that. I want to have the ability to quote unquote service this down the road. So I'm not looking to really crank down on these and cut them with no length at all left over. We're just trying to keep the bulk of it out of the way of the fans because, you know, fans are spinny movie things. We don't need to catch a wire in a fan and then cause an electrical short that way. I still need to do something with the beacon probe wire. Haven't quite decided what yet. Because this is the excess for the beacon probe wire. And I don't, the only way that you can make it shorter is to cut the far end and re-terminate that connector. And I don't have those connection pins. So what I do and what I did on my K3 was just kind of looped it in here. So I'll just find a place like this, throw a zip tie or two in it and kind of hold it there. Because it's just, yeah, you'll just sit in there and kind of flop a little bit, but that's okay. So we'll just kind of loop it in there or something like that. Maybe put a zip tie around, make an X right there, and we're good. So our whatchamacallit, our ground is going to come up here to the ground. We just need to figure out a good distance, flip it, and put on a terminal to it. And keep this stuff. This is good. This is some good ground wire right here. Correct. And you would do that normally because, you know, yeah, there is a chance for galvanic corrosion. I haven't ran into a galvanic corrosion issue, and that screw that we put in was black oxide coated, so that's got a rust preventative layer on it. And like I said, I haven't had a issue with any of my bed stuff yet. So, but it is something worth, you know, thinking on and you know, definitely good call out there. Okay. Always give a tug on those to make sure you're good. And once again, we're doubling up on the connectors here. Oh, darn it. We're doubling up on the connectors here. So we definitely want to make sure that the ends are together. In other words, one's facing, I'll say down, and one's facing up as it goes into the connector so that you get a better connection in there. I'm surprised they don't do Wagos. You've got plenty of room, and that might be something I do down the road is is just mount some Wago connectors here that we can come out to, come from here into the Wago, from the Wago to the power supply, and then to the bed and everything. It'll make this a little bit cleaner. And I am trying to leave a little bit of length here as well when I cut these. Okay. Like I said, one of these is going to go directly into the load, and then the other one is going to go into the SSR, and then we'll do a pigtail from the SSR to the, to the load. Yeah, I mean that it's not going to hurt, Kegel. It definitely won't hurt. But also, if galvanic corrosion is happening really fast, then you're in a very moist environment as well. And you've got other factors to be caring, or not caring about, but other factors to be addressing along the way as well. So I'm not saying ignore it, but I'm saying I don't know. It's kind of like at one point I had a instructor tell me, you can worry about everything, or you can worry about the things that really matter and that you care about. So, and that was in college. It was really related to, your scores and stuff. So, as a college student, you can be trying to get straight A's across the board in every class and become valedictorian and stuff like that. Unless your plan is to go to, an Ivy League college, why do you want to put that stress on yourself? Right? So in order to get to an Ivy League college, you're going to need a high grade in every single class, and that includes electives. Where if you're not, then do you need an A in, a foreign language, or do you just need to pass? Right. So it's really about how much time and resources do you have and where you put those resources. So same thing here is, everything we're doing here is a risk-based trade-off, right? You can always overspec your wires and all your connections, and it's perfectly fine to run bare wires into Wagos. But I go through and put ferrules on it. Why? Well, less chance. If I don't have wires that have a potential for fray, then I have less chance of an arc or something happening. And the trade-off is a couple of seconds of my time to do a ferrule. Right? Guess what we're going to use to do our pigtail? Because we don't need a huge amount here, I'm just going to snip one of these. We're going to use this to make the pigtail between the SSR and the load here. So yeah, it's all about risk mitigation and things like that. So if this is a business, right, I may do some things differently if this was for a business, right? I would have I wouldn't even be going in and firing it up at this point without having a secondary fuse and possibly RTV on that bed heater, right? Just because I was building it for a business and there's issues. If I was building for a business and this printer goes up in flames because of bad wiring, um, it's on me, and that means I've got to pay the insurance and pay out on that, right? So I would be doing things differently if this is a business than if it was for my house, which is what this is, right? And not saying that you wouldn't do that for your house either. It's just, once again, you put your time and your energy into the appropriate things. Oh yeah, yeah. So Miss Lee Marie, um, and I'm sorry, I can't remember your real name, and I hate using people's real name unless they've given me permission to anyhow. So, um, I know that you and your hubby do a lot of machine builds. It's pretty much been Voron. I know you're doing a positron as well. Do you do that just for you, or is that part of a, like, do you guys run a business? Like, I'm just curious, like, if you build printers for people as a business, or like, I'm just trying to figure it out because I do plan on making a business entity really to help offset the costs of going to all the shows and stuff and to enable future growth into other areas. So I'm just trying to pick everyone's brain. Get in there, little fucker. Okay. So the load of the power supply to the SSR to the bed, the return from the bed goes directly to the neutral of the power supply, and the ground of the bed goes directly to the ground on the power supply. And once again, you can double these up. They are made to be doubled up. Like I said, you want to take your connectors and you'll see on your crimp connectors how that connector is offset to one side. So you don't want to take your crimp connectors and stack them up in that orientation, because when you try and screw them down, they do this and you don't get as good a connection. If you have one that goes the opposite way, now you can get them a lot closer and they'll bend just enough as necessary on this end and you'll get a better connection. Preferably, I would love to have Wagos on there. And down the road, I may wind up redoing this wiring and incorporating some Wagos in here. But for now, it's going to be like this because I'm trying to evaluate. Okay, I don't do kit reviews or kit evaluations. What I do is I do these build experiences and I talk people through how I am building my printer. And I always try and build a kit like this. I build to the kit without mods to start with and then mod it. Right. So my LDO 2.4 is built as an LDO 2.4 with one exception. I didn't install Clicky. I installed CNC tap from the ground up because every single one of my Vorons has tap or had boop for the salad fork and the micron build. Um, I I don't like clicky. I don't know. I've just never done clicky. So I know people swear by it, and I'm good for that. I've never done clicky. Okay, now technically it tells us that we can close this up now, right? If we look at the thing here, once we get the bed done, it tells us verify that we completed the power wiring, right? So one link goes to neutral, the other link goes to the SSR and then out to load. And then install, oh, we got to install the AC cover. Yeah, this is a protection thing, right? So don't forget that, because what this is doing is this is going to sit right over the top and cover up all of that wiring. So there's no chance of hitting anything and short circuiting stuff, right? We're trying to prevent shock here. So we're going to put this cover on with, tell us what screws? M3x8 cap head screws. Let me find those. Belts. These are going to go right into these standoffs, maybe. Completely missed it. Feels like a couple of these are not going to make it. I don't know if the drill pattern was off or not, but quite honestly, if I screw down these three, it's going to hold it in place. It's going good. I'm trying to get this cover to go on and just trying to get the screws to line up in the little printed standoffs. They're not lining up, but it's cut acrylic going into printed standoffs. So if I can get a couple in here, I'm not gonna fret. Yep, that one's not lining up. I got two in. These are, you know, they're making the standoff. They're sitting on the standoffs, but they're not lining up with the screw holes. I'm not, like I said, I'm not going to fret about that. It does cover it up. Now the other thing that it never told me to do yet, and I don't know if it's going to be here on this, Yeah. So this piece here is, I'll say like a fan shroud that guides air over your drivers. And looks like this just clips on. And it looks like it just clips on to the board itself, maybe? How the hell is that going to clip on? Only way that, I don't even. So this is supposed to go over the fans. Maybe it's this way. Yeah, there we go. So this just clips on the fan. There we go. Clips on the fan and it directs these two right over the top of your TMC 2209 drivers. And it just friction fits around the edge of the fans. So we've got that now that covers the board. This fan is still pushing air in. It's getting over our Raspberry Pi. I still need to put a heat sink on that. I've got those somewhere. Okay. Got a straight copper one, or we have one with fins. Let's do one with fins. Put it right there. This is a Raspberry Pi 4, so it may actually run a little hot. So having a heat sink on it to help wick that heat away along with the fan might prove to be beneficial. Okay, Gold, why'd you do that? Now they're gonna get big egos. Now we love the Z and Z show. You also need to check out Wednesday's In Printing Color by Liz, where she talks about all of the cool colors and stuff that Polymaker's coming out, and just about any other filament as well. I'm also going to put one right there. This is I believe that's the memory chip there. How's it going, Timor? Failed P1S. The motor mount broke. That's weird. They did an exchange? Okay. Well, and Micro Center is kind of like one of their, I think they're a bamboo, some type of support center. Now, when you put this on, there are some resistors right around there. Make sure that you're not doing metal to metal on those resistors. Hey, Evil Diesel, how's it going? Oh, wait, we're supposed to learn on your stream? Okay, so we got that done. Like I said, this, I'm just going to throw a zip tie somewhere in here and zip tie it to one of the cross these here. Maybe. Zip tie. There we go. So we're just going to bring this up, run a zip tie around it, and that'll help hold that cable up out of the way. just like that. Okay. These 4 parts here are used to mount the electronics if we're not doing an enclosure, but we have the enclosure, so we will not need those parts. You know, I think I'm going to leave this open for the time being. I'll close that back panel up after the stream. See if we can spin this around without dropping the printer. Oh. And I do have a bench on the way for this. Well, I shouldn't say it's on the way. I have ordered the bench for this. So go ahead and get that turned back on. Now, okay, now that that's shut off. Yeah, by the way, that 4028 fan, it's pretty loud. It kind of rivals the CPAP that we put on the VZ bot for noise. We do have strain relief right here. Those are those 3 that we put in. That will give us the strain relief. And then our wires come down here. So that's done. I'll need to cut those 3 ends. And we're going to cut the ends and not any wires along the way. Okay. So wiring's done. We're back up and running. Oh yeah, yeah. And it does that every time you do a restart until the firmware comes up and talks to all the MCUs. So oh, that's nice, Timor. Oh no, I remember doing BIOS chips back in the day. TechnoSlide. We're here. We're here. You're learning a whole bunch about your XL right now. I bet you are. I only have to wait 5 to 10 years for my brain software to update. Yeah, there you go. So that fan is the part cooling fan, which is a 4028 12-volt fan. So it's 4040 28 millimeters high. It's a server fan is what it is. Me and Evil Diesel are very, very well used to those. So we got the bed wiring done. It does tell us to close up the panel. I'm going to wait until after the stream to do that. And we're on to PID tuning. Oh my gosh. Oh my gosh, we get to do PID tuning. Yay! PID tuning will sequentially power the heater on and off, understand its behavior, blah, blah, blah. Temperature parameter should be set to the temperature you expect to print at. You mainly print PLA, use 210. If you use PETG, 240 or 260 for ASA, ABS. You print everything from PLA to ABS regularly, pick a happy midpoint like 235. For one, we're going to click on here and come back to our RatOS. And we do have a PID calibrate hotend. Down here, we can click this, and it says by default the temp would be 230 or 220. We can change that or enter it. If you just say send, it'll do 220. I'm going to go ahead and tell it to do 245 because I print anything from PLA up to ABS, and when I do my ABS, I will normally go up all the way to 260. So now it's going to start that PID tune cycle. And once again, this is for the hot end, so it's doing the hot end now. Oh yeah, Evil Diesel, really. We lived in server rooms in our military career, and so how I can hear anything is a wonder. And so the other thing that I will do after stream is I will use the rest of our cable sleeving, and I will sleeve the cables as it comes down and goes into our cable area here and get everything zip tied at both ends. And then there's sleeving that can go around the PTFE tube that just makes it look nice. So I'll do that as well off stream. So I want to see how far we can get. PID tuning the hot end should go by very quickly. Doesn't take much. Regarding the bed temp, you can range from 60 for PLA to 85 for PETG and 110. So happy midpoint might be 90. Part cooling fan should be turned on during the calibration, as PID tuning must be performed in conditions as similar to a print as possible. Okay. Yes, I am going to 3D Printopia. I do have a table. Evil Diesel was still trying to figure out if he could secure a table or not. He hasn't heard anything back from him. But if not, then he will be at the table with me like he's been at the last several shows. We were just trying to get him a separate table so he could display some of his resin stuff. Hey, we're good. Now we can click Save Config. It does have our PID parameters here. We're going to save config, and it will auto update and go through a reboot of the firmware. Yeah. Now, are you guys going to be at the West 3D booth, or are you guys going to have your own table? So something I do want to do is preferably go to 285, and I didn't even check to see what the max is set on that thing. I hope it's set to 300 and not 280, because if not, it'll crash. You'll be with West 3D? Okay. Yeah, I'll definitely come around then, because I'll probably come by and get filament anyhow, but So what I'm doing is while I think about it, I want to get this up to temperature and find the wrenches. Find the wrenches. Where did I put the wrenches? I thought I put the wrenches in here. Did not put the wrenches in here. Where did I put the wrenches? Not there, not there, not there. So what I'm trying to do is find the wrenches so that I can do the heat tightening of the hot end. Not up there, not over there. Don't you just hate that when you know you had stuff laid out and then you can't figure out where you put it at? No, I didn't put them back in the box. What the hell did I do with those? Oh well. Pretty sure I didn't put them back in the box. Well, no, they weren't in the box. The good news is that I haven't heard it air out yet. Bad news is I can't seem to find my wrenches that came with the darn hot end so I can hot tighten this. You know what I'm going to do? I'm going to say it's all Evil Diesel's fault because he was over here and he must have distracted me at some point. And that's not true, but I always blame him. That was that. That was that. No, no. Ah, there they are. Okay, so we need to hot tighten both the extension and the nozzle itself. So we got the extension. I just tightened that up. Now I'm going to go in here and tighten the nozzle up to the extension. And I do that when it's at 285 because I should not be getting up above 285. So heat tightening at 285 is good. And then be careful of your wrenches because these are now super duper hot. So okay, so we've PID tuned the hot end. and we just did a hot end tighten. Means we should be able to put our silicone sock on now, preferably without burning ourselves. Like so. And while that's coming down, we can go ahead and start the PID tune for our bed. So we're going to do a PID calibrate bed. We'll click down, and we want to take this to 110 or 100. We'll be doing a lot of ABS and ASA with this because it's enclosed, and why not? Hey, Zombie, how's it going? Oh, thanks. We've had it moving. We're going through and doing PID tune now, and it's going to get loud because I'm going to have to turn the part cooling fan on. But we've got beacon working at least as a an eddy probe. It's not doing contact yet. I think we do have to do an update to do contact, or there's something else we need to do contact. So, but we do have the bed done now. So interestingly, on this Zombie, we do a home, a Z tilt, and then we run a bed mesh with a plain build plate, and we use the bed mesh to verify that our frame is square. That's pretty interesting. We're going to go ahead and send that command. It's going to start PID tuning the bed. And then once again, I need to, where's my fan? There's my fan. I need to turn this fan on. Assuming it's, I don't know. It may not do it until the, so this is a clipper thing where it's processing one command before it does the next. So I'm not sure if it'll actually run the fan or not. We'll see. Yes, there's a bunch of macros built into RatOS. But basically all it's doing is it's running the PID calibrate command at a certain temp. So that macro is just set to say both the PID calibrate for the hot end and the bed just says, here's my default. Unless you give me something else, I'm going to run the tool head at 220 for a PID and the bed at, I think it was 90, 80 or 90. You can PID calibrate a chamber heater if you have a chamber heater in this. We will also be doing the XY belt tension soon. And that's going to allow us to make sure that the tensions for our XY belts, the core XY belts, are good. We'll do that. Then once we're done with that, then we'll do the Y belt. We'll actually install the Y belts at that point. Because right now we still haven't installed the Y belts. Because if you add the Y belts in there when you do your core XY belt tensioning, it'll throw it off. So it does do a little bit of a weird commissioning compared to what we're used to. So while this is running, so in the commissioning process here, we do the build plate, then we do the bed wiring. So actually wire up the bed. Then we'll do a PID tune. We'll do the Z offset for beacon with, a hot build plate and a hot end. We'll do belt tensions. And once again, that's for the core XY belts. Then we'll install the hybrid belts. Then we'll do input shaping, skew calibration, and get into printing. I'm just trying to see what I need to do here. So while we're waiting for the PID tune to go, this one will take a little bit longer because we're heating up that build plate. So yeah, so far the RatOS is pretty neat. You can use RatOS for a V0 or a 2.4. So who knows? Maybe when I do my upgrade of my 0.1 to 0.2, I might just put RatOS on it. The other thing we noticed when we were going through and doing the configuration to start with, they do have the ability to run like the Orbiter 2 tool board, so the Orbital tool board. So if I do decide to swap that out on this one, then that works. If not, maybe I'll do it on the 0G Mercury 1. Have I peeked at the printer config? A little bit. Once again, it's doing its thing over here, so we'll come over to machine and take a look at the printer config. So you'll include the RatOS config, which is the information that's provided by the RatOS configuration tool. Right, so that will be the information you pick from your board and stuff like that. Then you'll have various macros that are listed here as variables and some basic steps. So you'll notice here that there's a call out for dir pen, rotation distance, homing speed, min, max, and end stop. So it's calling out a variable here for your direction pin, right? And it's got a stepper X, which is the lower left, your core XY. The X1 is the one at top, which is going to be one of your Ys. Your Y is your back right. Y1 is back upper right. You'll have Z front left, Z1 rear center, Z2 front right. Your extruder, which calls out the tool board, and then your heated bed. There's a baseline PID there. And there's the extruder PID that we just did. So this will get, this will be like the extruder where it will comment this out and add our true PID values down here at the bottom. The RatOS config, this is kind of everything else. This is based on the board you selected, and it goes through and basically does all the pin, or calls out all the pins for the board. So this is how it works. So if you choose a different board, it will go ahead and just, basically this is a pins file like you would get in Marlin. Oh, nice. And it's actually calling out specific parameters for the motors. You don't get that all the time. Yeah, that's pretty neat. So yeah, it completed the PID tune before it picked up on the fan command, because I should have turned the fan on then ran the PID tune. I'm good either way because yeah, I'm just good either way on that. It'll be okay. Thanks for the alert, zombie. So we've now PID tuned both the extruder and the bed. We need to do a Z offset beacon. So it comes with a fully automated beacon model and temperature offset. For further information, click here. The extruder and hot end must be clear of filament. There's no filament ever been in the machine, so it's pretty clear at this point. So we'll run this command to put the beacon into calibration mode. Download the first layer test. We just downloaded that. And we'll need to bring that in and first layer test. Oh, sorry, let me do full screen here. So we just brought in this first layer test, which is 50 by 180 by 0.25, which is our first layer height, or which is the layer height. So that's good there. I go ahead and make that just like that. Slice now. Send it over. Okay, so I'm just looking through here because I'm not sure what all it's going to, I'll say, ask me for. So I'm just trying to make sure, read ahead a little bit. Polylight blue. What do I want to use? What color do I want to use? I'm going to have to open up a spool unless I have one that's already open. Of course, the stuff that I know I have open is shoved underneath the thing here. So let me take a look and see what I've got. PLA wise. And of course, I want a color that I want or need a color that I can see and show well on screen. So I just need a lighter color. Go at the bottom and not go at the top where. Here we go. Go with a silver. Silver should be visible, right? Dang it. to the tool head at least. I'm going to have to clip that a little bit shorter. So I feel like I need to prime the nozzle first. Don't you? I mean, it's kind of hard for me to go in and say, hey, start running this command. We're going to be testing out first layer squish, and then I don't actually have any filament loaded up in there. So we're at 200. I'm going to run the load filament. Looks like it'll take it up to 220. Trying to do the install, and I don't think we're down in, or trying to load the filament, and I don't think we're down far enough. Load it into nozzle, okay. Let me do a extrude 50 at 5, sure, extrude. Okay, not sure if you guys are seeing this, but we're pushing plastic. Pushing plastic. No, you're not seeing it. Come back over here. We've pushed plastic. Now we need to grab that and clean it off. Make sure that we're clean there. Drop this back down to, I don't know, 140. And I'll clean that nozzle off again once we get there. What is this, 214? No, not 214. $217. Yeah. Okay. Okay, so we got that set up. We will generic PLA. So 5, 200. Should be good. We'll get that plate sliced. Go ahead and upload it. Okay. The nozzle's clean. There's nothing on the bed. Whoops. Grab this command here for the beacon calibration. Paste that. Home X and Y. Okay. So when it was starting that calibration, it very much looked like it was doing contact at the beginning. Now it's using the eddy coil. So in other words, the nozzle's not touching the bed at this point. Just homed without touching the bed. Just touch the nozzle. 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 So all of this that it's doing is automated based on the script that we just ran. I'm trying not to do any like movement or shifting my weight or anything like that to keep it as stable as possible while it's doing its thing. And I'm wondering if it was trying to do that first part with a cold nozzle and I had it at 140, so it may be screwing up the parameters because it just told it to go up to 150. We may have to let this cool down and then redo it. Now it's quote unquote waiting for the thermal expansion to happen. I think they need a note in that commissioning guide of saying like, hey, this is going to take a while, so be sure you have a fresh cup of coffee and okay, now it's bringing the tool head up to 250. It's going to let it soak for a couple of minutes, and then it'll do its probe again. So while we're waiting for this to do its thing, what's everybody else working on? Anybody got any cool projects going on? Any prep work for 3D Printopia? You know, I'm starting to look forward to 3D Printopia, but our schedule's just got, well, no, we're going to go to 3D Printopia, and then sometime after that, Mrs. Dragon is going to take off and go back to Colorado. going to leave from Colorado and go to Cleveland, Ohio for a conference, and then she'll come home from Cleveland, Ohio back to here. And originally we were planning on driving up together, and then she's got to go out to Colorado to do some things with her mom, so I kind of messed some of that up. We're working on adding the Big Tree Tech Eddy probe to your SP5 upgrades in Fusion. Nice. Finishing up the guitar, but my place is soaked in moisture. Can't print anything until I figure it out. Dry it. I mean, you've got a dryer, don't you? Evil Diesel? You got at least one of the Sunloos, right? You know, I haven't used the Big Tree Tech Eddy probe yet. My 2 Ender wire builds that are sitting downstairs that I may need to get up here and play with. Because I've got a guy at work that's really interested in buying a printer or 2 off me. So I need to make sure that those are good to go. And then those are using the standard, whatever those standard probes are for the stealth printer. They're the only ones I have that aren't running tap, because you can't run tap on a switch wire. Those would be the only ones that I would swap over to an Eddy at some point, because there would be drop-ins. But one of those things of run it till the wheels fall off and then go over to Eddy. And if I sell one or both of them, then wouldn't need to worry about it. It peels off the plate. That was your PLA print, right? You got any Vision Miner nanopolymer? Not, swing by tomorrow. Swing by tomorrow. Wash your build plate with Dawn dish soap. Dry it. Follow directions to put on your Vision Miner, and then let that dry for a minute or 2 and say go. I mean, unless you have standing water on your build plate, it'll work. Gotcha. Gotcha. Probing the nozzle at 250 now. Now it's dropping it back down to 150. Okay. Yeah, so I'm going to have to be working on some reorganization of my stuff over here on the side, because like right here where my setup was for the, yeah, I just have to fix this whole corner here, because I've got one of the RatOS workbenches for this coming. So I shouldn't say RatOS, RatRig. So workbenches and enclosures. So you've got the V-Hive enclosure kit, you've got the enclosure strictly for the 3, but they've also got these workbenches here. And these are all 4040 T-slot profile, and they've got them specifically sized for the printers. So they've got one for the VCore 4300, which is what we got here. They have one that will work for all of them. So it's big enough that you can put a 3 or 4 or 500 on it. And I'm getting the 300 size. Now you have to source your own tabletop, and it does, it will come just like this. So you'll have to source the tabletop, as well as you can put a table bottom on it or a shelf at the bottom for storage. But I plan on putting that right over here, kind of right next to the black box. It's what, 615 millimeters tall, I believe. So yeah, I'll be getting one of those once it ships. So this may stay up here for a little while until I get that other thing in, unless it takes a while to ship and get here. In which case I'll be like, well, I'll have to do something. It'll go on the ground for a while so I can work on something else up here. Still need to work on the Droid build for 3D Printopia. And still haven't got any shipment details on the positrons, so that's a ways off. Yeah, and by the way, Evil Diesel, if you're dealing with moisture issues, it's not going to get any better for the next few days. Not with the, yeah, it looks like it's going to be raining for the next few days at least because of the hurricane stuff coming up. So should be about ready to go into its next set. Been painful day. Yeah. I've been dealing with, so I went out yesterday, and ever since then my sinuses have been on tilt. I mean complete tilt. So I've been kind of a mess all day today. I was supposed to go into the office for our meeting and phoned in instead. Because between that and the migraine, this weather has been weird. And now it's going to go back up. Awesome. So we're going to cycle like this. So this is like a PID tune on steroids. So I think what I am going to do is shorten this PTFE tube some, because this is going to lead to issues with as long as it is right now. I'll wind up cutting it shorter just to make it easier to load filament and stuff. Well, I'll do that later. I really want to get done with this so that we can run a first layer print and we can get some squish and actually see a print going down. I think you guys are looking forward to seeing first real filament push. I know I am. Yeah, so the octopus is staying pretty cool with those two fans running over the top of it. Raspberry Pi is staying pretty cool as well. Once I close the back panel, it should get even better cooling going there. Oh, you met all the kids' teachers today, huh? Oh, okay. They got start of school got pushed back. That's always great. Gives the kiddo a couple more days to get on that sleep schedule, huh? Got one of my Nevermore fans starting to go out. She's not happy. She's bored, and it's okay. And it's crazy. Yeah. Yeah. I get it. I get it. She's all bored because she still doesn't have much to do. You know what you can do is start giving her like book reports. Make her read books and maybe an oral book report and just tell you about the book. Sorry, I'm over here sneaking a donut hole. Hey, I'm just looking out for her and trying to get her to, to. Oh, now it's heating the bed up. We may be here for a while, folks. Yeah, I'm just trying to get her, into the workload, school again. Don't get me in trouble though. Like I said, I've test fitted one of the panels. I did go through and put all of the foam tape around the ends. The two side panels are put on with a series of M6 by 12 screws with washers and locking nuts. And then the top panel will have a handle and some magnetic plates installed. And so the top panel and the front door panel will be put on with magnets. And that's what these are down here. These are all the magnetic pieces. So I've already got the magnets installed and glued in with super glue. So I've got these all ready to go. And then the other pieces, these will be mounted to the actual frame. And then these will be on the door and the top lid and get used as the joining magnets. And I did check the polarities on them, so those are right. Yeah, now it's dropping the hot end temperature down to 150, heating the bed up to 85. Got LEDs flicking like crazy right now. And it's got to be this, because this, I'm pretty sure, doesn't have the PWM command in it. So I will add that, because this flickering will drive me insane. Okay, so it's got the bed there. It's going to let it heat soak so it can fully expand and do its thing. Meanwhile, one of these is on. Iron Dragon. Bed heater, PWM cycle time. Copy. Machine. Anything custom you want to add or RatOS configuration you want to override, do it here. This section is pre-populated with the most common settings you may want to change. Recommended that you follow these steps to properly calibrate your printer. Blah, blah, blah. Sanity check and PID tuning done. Z Offset calibration, working on it. Pressure vent, screw correction, resonance compensation, working on it. Extruder, heater bed. We will save without a restart. That way, when we finally do the save and restart here, it'll pick that up so that when we go to turn on and do the next print, it won't flicker my lights and give me a seizure. And they really needed to let us know that this is going to be a long procedure. Oh, hey, Evil Diesel, have you been, did you get the non-solder connectors that you needed for the guitar, or were you trying to solder the guitar stuff? Did you need me to come over and do some of that for you? All right. Looks like it's getting ready to do its thing. Wow. Difference was 0.0004. Damn. Hey, Rack Outlaw, thank you for the follow. Oh, cool. Okay. I think if I saw it right, it's trying to evaluate racking of the, or twist and rack of the gantry right now. Rack Outlaw, what we're doing is we're going through the setup process on the RatRig B-Core 4 300. And right now we were doing the beacon calibration. Okay, so it just saved and restarted. Okay, I want to take a look at that again. So let me see the console. So last reading, blah, 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 blah. Very low gantry twist. No beacon scan compensation needed. So that's good. Yeah. Average latency 2, excellent performance for a typical printer. Great, great. All right, so we've done our beacon calibration. So we did the initial Z offset for the beacon, or actually the beacon calibration. Now we're going to do a print, and during this one layer print, we need to adjust our Z offset using the mainsail interface, and when we're ready, we need to click save, and we need to do that during the print. If we don't, then it won't save that Z offset. So we've gone ahead and we got a first layer test already created. We've got their file created and sliced, ready to go and uploaded. So we're just going to tell it to print. And this will be our first print on the printer. We'll come down here and we'll get ready to adjust our Z offset. And we're going to be looking for the right squish based on this. If we're too low, we're going to start getting gaps and tears and ridges. If we're too high, we'll get gaps between the lines or they'll barely stick. What we want is kind of right there in that zone between these two. Once we get there, we'll click save and save that Z offset, and that will save it into our configuration. Wonder through the overhead view and turn it. Got the overhead and the side view. Right now we're heating up. Head overshot a ways. The good news is we got the PWM set, so my lights aren't flickering anymore. So I'm not going to have a stroke seizure. I was sitting there like, why did the bed overshoot? The bed didn't overshoot. The bed was still coming down from the beacon calibration test. So cool off. Yes, once again, We'll get our first print going here, and what's after this first print? We'll work on belt tension after we get the Z offset. So yeah. We'll do this. We'll have to do the belt tensioning for the Core XY system. And then once we're done there, it'll be adding the Y belts and then some other printing tests like pressure advance and standard tuning. Let's do it at Z tilt adjust. Okay, and it's doing its purge line. Looked like it was going to be doing a purge line. Guess not. It's doing actual contact right now. Adaptive mesh. Bringing the extruder up to 205. Doing a priming blob. Dude, may not need to adjust this at all. Nope, maybe a tad bit down. Try and bring you guys in here a little bit closer. So we're getting good stick, but you can see that we've got a little bit of gap here around the front corners that I'm trying, and so I dropped it down some. And I'm not feeling a ridge. I kind of like that right there. Okay, so let me switch the camera view. Fix that. Okay. Change camera view. Okay, so it came up to the front and it did this initial purge blob here, right? So we got a purge blob and a drag wipe, right? And then it came up and it was doing the outline, but you'll notice right here that we were getting some gap. Now that's probably some pressure advance and square corner velocity right there. But then as we were going, we were getting a little bit of gappage there. So I dropped it down a little bit. I feel no ridges whatsoever in this print. So I think we're good there. And we'll have to validate that with another print. But I think we're pretty good there. I dropped it down, I think 0.25. So, but everything stuck nicely, even though it wasn't fully squished. And this will be the test when I go to peel this up. So everything's there. The first layer is fine. Okay, so down here it broke away, which I expected because it was a little high. Up here we're fully down. That's a good first layer right there. If you can't pull the layer lines apart and you're not getting the ridges, that's a good first layer. Hey, Liz. So we got our Z offset and we're going to hit save config just to make sure that that does get saved. Bum, bum, bum. But Z offset, we dropped it, we dropped it, we dropped it. Z offset, apply to probe, save Z offset. Cleaned up and we did another restart. So where are we at now? Next up is going to be belt tensioning. So ideally the belt graph for V-Core 4 would have smooth lines and two peaks like this. So that's what we're going to be looking for. To perform the belt tension graph, just click the designated button below. Measure core XY belt tension. The slicer overrides it if you set your slicer up to do that. All right, I'm going to copy that out and I'll Where's Notepad? I'll copy that out and keep that in my back pocket of Rack Outlaw. So thank you for that comment. So we need to run the belt tension. And just because I want to make sure and clean up the tip of my hot end. I'm going to home all. Okay, and now we're going to run the measure core XY belt tension command. Starts at 10, goes to 133 by default. So I'm going to grab that and say send. So it's now going to do a belt tension test. The Rack Outlaw, was that on a printer running Rat OS, or was that on something else where you had that issue? Because I'm not sure, I'm not fully sure how Rat OS is saving that. That was Rat OS? Okay, good. And which version of Rat OS? Because I'm running the 2.1.0 release candidate 2. In Orca Slicer 2.1.1R. Okay. I'll tell you what, with the frequencies that it's running at, it's a lot quieter than a Voron is. Normally the Voron's making a hell of a racket by now. All right, heavy resonance in the mid 80s, and then it drops back off. Generating the belt tension graph. Oh, nice. They actually provide the graph right here. Damn. That's all I'm going to say right now is damn. That's probably the prettiest first run belt tension or input shaping graph that I have ever had. So, go to the prepare tab under the printer, look at it, go to machine G code. If you added all the beacon probe touch stuff there, where that section is that I pasted was overriding the save of the. So I actually came in here and wiped everything out and replaced it with just what it said to do in the setup config. So, all right, Evil Diesel, not a problem. So, yeah, so I just basically did the thing, which was start print, extruder temp, bed temp, and you're done. And everything else is done in the macros within Clipper. So those same commands that you were adding in here, you could actually just put in Clipper and it would be good to go as well. But yeah, I mean, this little blob right here is the only thing that I see potentially as an issue. So this little wobble right here is the only thing. Yeah. And let me bring that up, a full size. Really? No way. So this is the seriously? The lower. So the lower belt, which is the right rear of the Y motor, has the extra little blip in it down here, but I'm pretty damn good with these graphs. I mean, yeah, that's right around where I was hearing some extra noise. What would you say, Rack Outlaw? Do we need to add a tiny bit of tension to one of these? Or do we leave well enough alone and not try and chase it? Yeah, exactly. Every time I try and chase something like that, it turns into a nightmare. Yours is not that good? Yeah, like I said, that is the best input shaping graph I have ever seen on one of my printers. So I'm fat, dumb, and happy there. Now, mind you, when we built this, we Loctited all the screws that were going metal to metal. So we've Loctited all the screws on the XY joiner plates, the plate that's mounting um, the whole print or the print head to the X gantry was done with um, Loctite screws. So everything was that could be Loctited was Loctited. So that's I'm happy, and this is the comment that they say here is. So here it says only one belt path is having an issue. What are we doing? Okay, so this extra vibration over here, it says could be caused by a loose screw, damaged printed parts, loose wires, lack of zip ties. I've got everything zip tied up. Um, but yeah, I'm pretty good with that little bobble that we had there. Okay, so this is the one saying that one of the belts has an issue and is rubbing somewhere. So that could be something that we can look at is the lower belt maybe rubbing on something. I mean, not noticing anything. But yeah, like I said, I'm good with that for now. Lastly, it's important to differentiate between vibrations and swinging. Vibrations manifest in zigzags, okay, and are mostly caused by loose screws on the tool head or the gantry. Loose idler stacks or missing shims can cause the same effect. Swinging does show as smooth curves. Many times it's coming from the fact that the printer sits on a shaky table or an uneven floor. That could be what we're seeing because my feet are not fully flat on the top surface. They're partway on this, like the metal front and back edge and the table. So that may be just the fact of the table that it's sitting on. Hybrid belts. Tuning all belts from the ground up is nearly impossible, so they recommend you first tune the Core XY belts and only then proceed to add and tune the Y belts. The Y belts must be tuned recurring to the input shaper graphs. Slowly tensioning them equally, starting with a low tension, is important to understand. The hybrid Core XY input shaper is much more sensible than a normal Core XY setup. A very small increase in the Y tension can change a perfect input shaper to the worst one you have ever seen. Sweet. So now we get to come in and add our Y belts. Both belts must be pre-cut to your machine size. For a 300 by 300, we need 1,110 millimeters. Awesome. That means I need to get my meter stick out. So, got the meter stick out. Let's see where we're at. Let's go to the fixed side view. So we home tape. What do we got where? I feel so I need 2 links. Here we go. Of 1,110 millimeters. Take that and throw it down there. Take our meter stick. Come on. 1. We need 110. $1,110. Just going to double verify that. Come on now. Couple extra. We're all good. Couple extra millimeters. So we're going to set up our belts like normal. The one we just cut goes 1 down. No. The one we just cut goes 1 up. We just match them up and pull it through. And the first exposed valley is the one that we cut, and that will be 2 equal belts. And pretty close to having a spare third one if we needed. So nicely enough, they do give us plenty of belt. Your 500 has been fun. Yeah. You know, the more I think about it, I was like, I don't need the 500 because it's going to be really big, right? And especially with the size of this 300, it's really big. But the more I think about it, I'm like, well, the 500 would have been cool. So maybe, you know, down the road, maybe I'll get a 500. Both belts must have the same length so they can be easily tensioned later. Yep. We're going to prepare the following parts. Bum, 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 bum. start it. There's a few printed parts we're going to need. And we'll need some screws and stuff. I think I may have just pulled forward, so I think we're good. Because they're going to be M3 by 8s, which I have, and M3 by 12s. So the M3 by 8s right there. Both of those are M3 by 8 cap head screws. Need M3 by 12s. There's the M3 by 12s. All right, what is it that we're going to do? With our printed parts that already have heat set inserts in them. Yay! Install the Y-belt parts. Sure the belt grooves face the inside of the machine. Okay. Two M3 by 12 cap head screws feed the M3 by 12 cap head screws through the VC4 belt body. Tighten them into the threads on the joint plate. So what we're going to do is come through the middle two holes here, and we're going to do it with the belts facing the inside, and these are going to sit right down on the other screws just like that. We'll put in some M3 by 12s. Now this will be going into the metal plate, but we're going through a printed part, so I don't really want to put any Loctite on here so we don't damage, or not damage, but yeah, cause the printed part to fail over time. Grab my ball head screwdriver because I don't know about my length that I have available to me. M3 by 12. Yeah, I think doing a 500 would be pretty cool, and it would give me an even larger size, but at that point, then I'm going to have to get rid of like maybe the 350 Trident. Because I really like my 0G, well, my Inter 5 Plus turned 0G, which would be 370 by 370. By what, 420? So I really like that setup. And then the Trident could find a new home, and that would make room for another large printer that I could use to do larger things, or do things like, you know, print the parts for a V-chunk. Okay, and that's screwed down on there, both sides now. route the top Y belt. Here the teeth are facing the stepper motor pulley. Take one end of the Y belt, feed it as shown. Okay. So one of our Y belts, we need to make sure that our the words on our belts are facing the right way so they're readable. If you put them the wrong way, it'll affect your input shaper results. So I've heard. Wrap around, wrap around. Side. Here we go. That's going to get us around the pulley. You'll see this better when I do it on the other side, but now just trying to get this around here. There we go. This belt looping in on itself. Insert one end. Printed part slot. Okay, so it comes up, goes up and around, and then back around and down. Good gracious. Kind of a bit of a convoluted belt path. Try and get it lined up and down in there. Going up around the pulley. Around the back. Something's not right there. All right, let me go over and do the other side, which is what it's showing me. So this goes up. So we go around the back of the pulley, going around the back of the pulley, or around the idler, around the pulley, back around here. Making sense so far. right? So idler, so around the back of the idler, around the pulley, the back side of the belt goes against the front idler here, comes in, does the loop around, so the teeth are kind of facing outward here. We're doing what I'll refer to as sadomasochistic belt pathing. Meaning so many twists and turns, trying to get the belt to go down in there. Kind of a pain in the tuchus. And you might need to take like a slotted screwdriver and push it down in there. Gently, of course. Because you do want your belts to be fully seated. Okay, so we're nice and flush. Come around this idler, around the pulley, around the other idler. Now we're coming back up, and I don't see how this. Oh, I'm an idiot. Yes, I am. I'm an idiot. Yes, I am. Pay attention to the belt routing, folks. So you do want the teeth of the belt to be lined up. That's where I was missing it. So it comes here, goes around the rear pulley, or around the rear idler, around your pulley, around the front idler, then comes along the front, around your front tensioner idler, and back up and in. Come on, darn it. Hey, Stone Monkey Research, how's it going? Welcome on in. We're having a grand old time. We're working on adding the belts for the hybrid Y motors. So these are the, I'll call them the secondary belts. For the Y. Which is going to be a pain in the butt. Get up here so I can see a little bit better. If I can get it all the way around here, it's just when it starts to lock in with the other one that it starts becoming a pain in the butt to get in. And this is where I made my statement about a masochistic belt path. All about trying to get the right curvature in the belt there to get it to start going down in the slot. We were off by like one. Off by one tooth. Of course, you gotta be careful trying to get the belt down in there that you don't rip it or damage it, but or break the part. This is definitely the pain in the ass part of this entire build right here. And I'll say it was just as much fun on the K3 doing the K3 belt pass. But at least there I could cuss myself out because I had printed the parts. So the fact that my parts were a little probably over extruded, that was, you know, I only had myself to blame. These parts were printed by the factory. So okay. I'll have to keep playing with that. All we're trying to do is get this belt fully down there and kind of at the same level of the printed part. And all the way around here, it's not that bad because it's just a single belt. It's right about here, this last section right here, where you're going belt to belt. That it gets a little bit tight. All right. We're not going to fret too much more about that one because if I do, I'm going to get upset. Come in, go around, and we're going to stick out a little bit. Yeah, I've got the enclosure frame. I do have the enclosure frame. Yeah, I ordered it with the enclosure, the hybrid motor, and I didn't get the IDEX because it wasn't available at the time. So the IDEX will be added later on. The nice thing is there's no more motors when you go to the IDEX version. So at that point, it's just going to be some configurations and stuff. drop back down off here. Oh. So we're coming up, going around the back side of this idler and in front of our pulley. We'll go around our pulley and the other idler. Dang it. Oh. Come back around here. And shove that down in the belt pathway. And once again, it works pretty well until you start to get to the spot where the two belts need to interleave, and then it becomes problematic again. Because why not? Why not? What did you miss? Well, we were just chatting about the frame. So I did get the enclosure. I did get the hybrid motor. So I didn't think there was a difference in the frame whether you had the enclosure or not. I did get the hybrid motor kit. The IDEX was not available at the time, so who knows, I might get the IDEX kit down the road. We shall see. Come on, belt, work with me. Work with me. Like I said, it's that section right where you wind up getting all four belts side by side, and it just gets really tight in there. Probably need a thinner screwdriver. There we go. Trying to get the belt down in there without breaking the printed part or ripping the belt, which would defeat the purpose. And of course, like I said, this is kind of the pain in the butt part. And it's about the same spot where I had issues with the Annex K3 build because I think I had a little bit of over extrusion in my parts, which made the belt path areas really tight. But I can say here that, well, these are factory parts. So I bought my kit and it's a full and complete kit. So it includes all the parts, all the printed parts, and all the printed parts already had all the heat set inserts in, which is really cool. But even better is they provide all the heat set inserts. So if for whatever reason you wanted to change the color and print your own parts, you could, and you would have the needed heat set inserts to do that. Or if you ever had to reprint some parts because you broke them, you could. Okay. That's about as close as I'm going to get them. They're still riding up a little bit right there. And it's that secondary, whichever one was the secondary that I was putting in is the one that's still riding up a bit. I'll continue to play with these and again, try and keep working them down in there. But I do need to go ahead and trim off the excess. Just because I don't want them to be in the way. And the good news is, even doing that blind, because I didn't count the number of teeth, I did just cut off the same number of of teeth. Okay, so we've got both of these routed. And we're going to put the lids on them. Now these lids have flat bottoms, so we really do need to try and get these tails all the way down in there. That worked. Close enough when I do these other pieces that I'll push it down in there. So we're going to need some M3x8s. And the caps are going to go on there, and we'll put in our M3x8s. Just tighten the cap down. This gives it a nice clean look and also makes it so that the belts cannot jump out and get away. And by tightening these down on there, we are, in essence, clamping those belts on there so they're not going to go anywhere. Done there. Three over on this side. Okay, so that's on there. Everything's tightened down. Now it wants us to loosen the set screws and move our gantry around. So I'm not going to do that, or not what I was going to do. So let me shut this down. That will de-energize my motors because they don't have a like the motor, whatchamacallit. Seriously? Let's turn the printer off. Now I should not have any energized motor. I'm going to rotate this around some. And I want to look at these belts. And if the belts are riding on one edge or the other, we want to move our pulleys. And they are. So I'm going to make it so I can get to my pulley set screws. And then we'll move the pulleys up or down and lock them back in. So left side needed to go up a little bit, and this other one needed to go down a hair. Get them locked in there and move them around again. Make sure they're tracking in the center and they're not dragging on an edge. You really just need to push it forward and back because that's the only thing that's going to change. Or the only thing that's going to move the pulleys that we're working on. Okay, and I like the look of that now. Both of those are there. Both of them are tightened down. So we can turn the, well, I think we're going to turn the printer on, but let me double check. Tighten the stepper pulleys. We did that. Tension the belts. Just both belt tension in a progressive and equal way. Do not over tighten, as it will mess with your performance. These are M4 cap heads, so we'll need our 3mm. And I'm just trying to do this by hand right now to figure out the feel. And I think they feel about right. We'll see what Input Shaper says about it. Come back over here to our commissioning guide. Tension your Y belts. It's important to tension both belts with the same force. Try to rotate both tensioner screws by the same amount. It's easy to ensure your belt tension. It's easy to ensure you tension both belts by the same amount by verifying if the gantry is straight. 4XY gantry alignment guide can be used here, but only regulate the top Y tensioners to align the gantry. So once again, we'll bring this all the way forward. And we're going to look for our gaps. All the way forward. I think we're there. We're going to be a good start. So I guess it's saying generate input shaper graphs now. So let's turn it on. Come on. There we go. Man, that fan is loud. Okay. And like I said, the commissioning guide, it's got highlighted around the input shaper graphs now. So you're looking to achieve a clean input shaper graph. So we will come down here and run the input shaper. So generate input shaping graphs. I think it's going to do a home. Yeah, they're roughly the same. And we're starting the input shaper frequencies. So and I'm curious because it was the low to mid 80s where we picked up a vibration initially. So I'm curious to see if that's still there. So it's dropped down into the low 70s. And 85 and up, it drops off. So there was the first peak. Yeah, and Rack Outlaw, I don't know how much is different between the VCore 3 and the 4. I never had a 3 before. This is my first ever RatRig of any type. And I'm curious to see if this messes with our input shaper based on the first graph that we had. And if it does, then we may loosen these up a little bit and keep trying. Okay, so now we're getting interesting. Low 60s. We got some noticeable louder vibrations. Yeah, I think on the 3, wasn't there like a top hat for the 3 if you went to enclose it? Okay, so shaper's done. Generate X, generate Y. Man, MZVet at 74.6. There's a darn nice input shaper graph. There's a little bit of noise out here at the end, but not a lot. And this one is beautiful. X is MZ Victor, MZV. This is ZV. A lot more noise there, so I'm wondering if I'm too tight or too loose. So I'm going to drop these about a quarter turn, make them a tiny bit looser on the Y. And run that again just to see what we get. Shouldn't change our X at all. Should not change our X at all with what we did, so. Because the only thing that I touched was the Y. And granted, we don't have any sides on, and we have a spool in the spool holder, but that's semi-close to a printing configuration. So I'll say Phantom, Phoenix, Gussie Marie, Macite, Moto Freak, Mr. Wizix, Pez Liz, Rack Outlaw, Rodney Mac, Lab Station, The Reverend 64, Free Heathen, Shrimp Father, Timor, Warwick B, and Zombie Hedgehog. Thank you all for continuing to be here as we go through this. Sorry about that. Hey, West31, how are you doing, sis? Hope you're hanging in there. Hope the little fur babies are treating you well. We are working on some input shaping. We did our first layer test on this, so we have pushed filament on this printer already. Right now, what we're working on is our belts. We did a belt tension graph, and that set our core XY belts, the upper and lower belts. Then we've added on our Y belts, the extra hybrid motor Y belts on each side. And now we're running some graphs just to see if they're too tight, not tight enough type thing on those. That's kind of what we're doing right now. That looks like it is finished and it is doing its graphs. There we go. So the last time our X looked good and our X looks beautiful still, which we expected that. The only change we made was to Y. Now what we want to look at is this little area down here. Okay. And I'm going to desk scroll some to, or actually, you see, okay, so I'm going to go to full screen over here. Now what you're seeing is this one here on the left was the first one we did. And if I can line this up right, about there. You'll see this is the first one we did. We had this little bobble and then a spike right here about whatever the line is before 100. And I loosened my Y belts about a quarter turn on each side. And this was the new graph that was generated. You'll see it dropped down a little bit lower. Yeah, so it dropped down a little bit lower and it didn't spike up. It's not a spike, it's more of a rounded fall off. So I'm wondering if we loosen these up maybe another quarter turn, if that'll get better or worse. So I'll right click this, save image as. And we'll go through and run that one more time. Once again, we're just trying to dial it in and make it the best that we can get. And once we like it, we'll go ahead and save. Once again, what we're looking for is a single spike, and it comes right back down and smooths out. This is like perfectly ideal, and this is what we're seeing in our X. Our Y is a little noisy. That's what we're trying to do, is get rid of that a little bit. Yeah, Westery, how are you? Yeah, how are you doing? Are you hanging in there? I hope so. I hope so. Hanging in there good. Good, good, good. Oh, goodness. Oh, man. Well, do you know how to weld? Can you weld it back together? Okay, it's going to generate our graphs again. Okay, so our Y getting smoother, but it's still I don't know if it's a bolt broke. Okay. Oh, wow. Okay. Um like, I'm looking at this and I'm trying to figure out, am I going the right direction or should I be tightening it? Because this is my first one here. I mean, it is coming down. That spike went up a little bit, but it's curving down. Do ZV at 57.8. Now it's saying MZV at 55. All right. So the first graph on the left, which started out at a half turn tighter, so there's the half turn. I went 3/4 of a turn tighter. There's a half, and there's a quarter. All right, one more try, and I'm going to see if the sorry. What I'm trying to do is see if it if those extra Y belts want to be tighter or looser. Trying to gauge the change in the graphs. Was it rusted at all, or was it just maybe like the wrong type of material? Like it wasn't the right grade of bolt? It's kind of like what I would be wondering is if it was the wrong grade of bolt that somebody put in there. Hey, Print Busters 3D, welcome on in. Thank you for the follow. So I know it doesn't look like there's a lot going on right now. What we're doing is running our input shaper over and over and trying to tweak the belt tension on the hybrid Y belts. And right now I'm trying to figure out, like, I had them tensioned by hand. I had the initial graph, which was here, which wasn't bad. There's just a little bit of artifacting after the fact. And so I stepped it, you know, I loosened them a quarter turn once and then twice. And now what I just did was I went ahead, you know, I went back to that half turn and then forward an extra quarter turn. And I'm going to see if the graph got better or worse, so I know which way to keep moving the, you know, tightening or loosening, basically. My X graph looks gorgeous. I mean, that's awesome. It's still the Y graph of whether or not, you know, what I'm trying to work on. Here's my X graph, and that looks awesome. My Y graph, so this was going a little bit tighter than this first one on the left. And we still get this bobble, although it's not as pronounced. And this isn't as sharp, it's rounding off. I'm going to try one more quarter turn. On both sides. And we'll give it one more shot. And I'll just have to keep looking at these offline just to kind of mull through them a little bit more. But I'll tell you what, the input shaper graphs, excuse me, that I am getting off this printer are probably the best input shaper graphs I've had on any printer so far. Now, I haven't done input shaper on the black box yet. That is coming up here shortly. So that one's going to be a little bit different, but I just got in some new panels from KB3D Chris and some parts to make some modifications to the printer. So I'll have to go through and do that, and then once I'm done there, power went off on standby generator now. Oh no. What can I ask, like, what state you're in, Rack Outlaw? I'm up in North Carolina, and we've had rain. We haven't had a lot of wind just yet, but we had some rain. I think it stopped. Yeah, supposedly it's, I don't know, it's still light raining going on. And then it's supposed to rain again starting tomorrow and just, yeah, just keep going. For like the next couple days. Georgia, okay. I'm just curious to see like how it's progressing is really what I'm trying to And of course, the weather app does not feel like it wants to show me the actual radar maps at this point. Hasn't been bad today. The wind was not that bad outside. Yeah, well, and my internet blipped 2 or 3 times today during the middle of the day, which was annoying as all get out because I was sitting there in meetings. And sorry, and we didn't have a lot of rain going on, but what we do have is we have crews in the area that are running new lines, and they've taken out a water connection, they took out a power connection, and they've taken out an internet connection down the main road outside my neighborhood as they've been trenching and pulling the, I believe it's Spectrum bringing fiber into the area. And yesterday, I think it was yesterday, they were out, or actually over the weekend, they came out and like marked all the yards in the neighborhood. So they're going to be pulling in through here in the next few days, which will be great because I'm looking forward to them busting my internet even more. Okay, and this was the initial. So making it tighter has smoothed this out at the end, and this bump is getting better. I don't think I want to keep chasing this, or at least not now. I say that and I look at these graphs and I'm like, well, maybe, I don't know. Yeah, let's go ahead and that's what's killing me is my X graph is suggesting using Z Victor, right, at 73.4 hertz, max acceleration at 21,000. My Y is telling me to use MZ Victor with an acceleration of 10.5. So technically you'd want to set your acceleration to 10.5, which is the lower, and we'll put in our frequency and input shaper type in here. So that's what we'll go for right now. We'll come into our printer config. We'll come down to, I believe it's down here at the bottom. Apparently not. Okay, in the user override section, paste the following line. Okay. So we'll just add this somewhere. Put it down here at the bottom. Okay, the X frequency based on our run, which I've now covered up. That so I can pull those up. Okay, so machine, printer, scroll down to the bottom. For Y, it is suggesting MZV, MZV, and 59.6. For X, it's looking for ZV at 73.4. Okay, and we will save and exit, and I'm actually going to do a restart. Skew calibration. So skew correction is meant to compensate for 3D printer assembly, which is not perfectly square. Okay. V4 has a 3-point kinematic bed leveling system that helps mask XZ and YZ skew problems. Build was successful and all Z rails are properly aligned. The Z squareness shouldn't be a problem. In this guide, you'll only focus on the XY plane. The procedure is the same for the other axes. More info here. So start by downloading the Skew Correction tool. Okay. And slicing the model, make sure the A corner is pointing to the origin of the plane. Guarantee that no skew correction is running on your machine. Check the variable skew profile is commented out in the macro configuration section, or type the command below in the terminal for more information. So we'll set this okay, so it looks like we're going to run a print. So we'll grab that, delete it. We'll keep our same profile. So, and A is into the corner plane. So that's correct. Slice that plate. We'll tell it to upload and print. So it should automatically get that started. All right. We're going to get another print going on here finally. Looks like we'll be doing measurements off of this print. So we're currently printing with a Polymaker silver. And provided our first layer gets picked up, I mean, that was our initial first layer test for print. And that came out beautiful. I'm feeling no ridges whatsoever on it. We're definitely got good layer adhesion or not layer adhesion because it's a single layer, but you know, adhesion on the lines. Doing a bed mesh. Now it's going to heat up the rest of the way. And this is the base macros. I haven't changed any of the macros. This is what it does at the beginning of every print. And if I continue to get very consistent first layers, I'm fine with that. I'm going to come up to this front corner here and it's going to do a purge blob. And then pull back and do a wipe. And then I'll go and start the skirt and everything. And there's the print cooling fan. Could definitely use a panel or two. About 75 decibels at a meter. Okay, and I did not realize I was trying to check the decibel meter, and we're at like 75 decibels at a meter away. And I just stopped this because it's printing like crap, and I believe it's just a temperature issue. So the one we shouldn't be overrunning the hot end because the hot end is a Rapido 2 ultra high flow config. What's happening is we are I've got a hardened nozzle on it, and the temperature dropped at the second layer. So combine that with the hot end fan, or the part cooling fan going full tilt. It was cooling the part or the filament too fast. So what I need to do is increase the temps. We're going to go to 220. on the temps. And we will try that again. Yeah, I just cranked it up to 220. And quite honestly, that's where I normally print Polymaker at. Come to Papa. Make sure that I don't have any oozing sitting out there. Yeah, that's normally where I print at, and I didn't even think about the it dropping down in that default profile. But yeah, using this is a meter stick, right? Meter stick, and using this from the corner of the frame with a decibel meter, I was getting 75 decibels with that fan just sitting a meter away. So yeah, that fan is outrageous. I'm gonna have to get panels on this sucker. Yeah, this is definitely going to be something. That fan is crazy though. I may have to drop the fan RPMs down some because that 100% is crazy loud. Actually, I'm half tempted to put, like I said, I've got one side of the panel set up, and I had it on. I'm gonna try and put it on. Oh, geez. Really? See if I can at least drive it from one side and hide behind a panel. Dang it. Hey, Slab Stations. I'm going to turn that fan down a little bit. Oh, dear God, that helped. So slab stations, we're going through the commissioning guide, and part of the commissioning guide, we do the initial beacon calibrate, and it does set up beacon contact. So when it does its home, it'll do beacon contact. Then when it does the Z tilt, it does the eddy coil, and then it'll go through and do the bed mesh with the eddy coil. So the long story short, yes, that is set up. We did input shaping. Let me pull up those graphs. Okay, so I'm going to switch over to the full display here while this prints. So this set of graphs is the belts. And this was the belt tension that we ran when we just had the Core XY belts on, right? And so we were looking for the two peaks. There's a little bit here on the Y that we're still looking at and trying to figure out. But we then added the Y belts. And by the way, this is one of the cleanest graphs I have ever had on any of my printers. And then we did the input shaping. And once again, this is the X, right? Single spike, little wave down here, and it smooths out. The Y, single spike, and then we get a little bit of noise down here. And I'm still playing around with this, trying to figure out, is it, do I run it a little looser? Do I run it a little tighter, right? So that's where we're at on that right now. But input shaper looking really good. We do have beacon contact up. We have input shaper up. What we're doing now is the skew correction. So this is going to be a test print, basically. We're going to measure points on this, and we'll add that in, and it will automatically do the skew correction for us. And once again, we're following the commissioning guide, which says print this out. Ooh, you know what, guys? I forgot to do the set skew clear. I forgot to add that in there. To guarantee that no skew correction was running. I guess we'll take a quick look. So there's nothing there. Okay. Well, we're guaranteed we don't need to worry about that because we have no skew correction set up, at least not in the printer config, right? We don't have that set up. Just digging through here and making sure, yeah, there's no skew correction set up yet, so we're good there. And I have a 0.6 nozzle in here. I'm using the default RatRig hybrid profile for 0.6 nozzle. The only difference I've made is changing the first layer height to 0.25. But yeah, so far everything's going good. I like how it does that little print blob to make sure that it's got a primed nozzle rather than just a prime line. So what'll be next after we do our skew correction? Start printing. And at that point, that's where we'll go in and sorry. When we're done here, what we would do is start running through the standard config stuff or not config, but tuning tests in Orca Slicer. And we'll just set up and run through those, check our extrusion multiplier and all that goodness. Now, let's say we probably have some pressure advance to work on. Some square corner, some pressure advance. A little bit of tuning to work on. Let that cool off a bit. But we're going to need to check some numbers here. So we need A to C, B to D, and A to D. But so far, our first layer of squish is pretty good. Like I said, we're printing with PLA to start with. I'll be working on getting some panels on just because that fan is hella loud. Okay, so we need to check A to C. Well, let's make it. $121.25. B to D. It's the other corner. $101.04. And then A to D. Let me redo that. We said B to D, right? Was the second one? $141.63. I have a feeling my calipers need to be like I need a new battery or something. B to D, and we want to go A to C then for the other one. $141.12. And then A to D. A to D. $101.85. Okay. So we've got our numbers. Now we're going to need to add a line called variable view profile. So we're going to add this. I'm just going to go ahead and do it right at the top. keep the parentheses in there. We're going to say set skew equals 141.12, 141.63, 101.85. And apparently no. Okay. And variable skew profile. Variable skew profile. Skew. I'm so confused. Go into the printer config and add the following line. Okay. So let's just come back in here and we'll add the following line. Not what I wanted. We're going to add that line. Save. Okay. Now, click save and restart, then paste this. Okay, so we need to save and restart. Yeah, exactly. I had a feeling that was going to. Will it let me run a command? Set skew XY 141.12. For 1.12, 141.3, 101.85. Ah! Ah, that be why there's no, that would be why. Syntax, folks, syntax. It matters. Okay. Now we're going to do that. Do that. Skew correction state has been saved. Save config command will update the printer config and restart the printer. Okay. There we go. Skew correction is there. Skew correction is there. Hey, Gulsfer. Yep. Hey, Liz, you're still here. Wow. Yeah. I'm trying to get through this. We just did the skew correction. And hey, it says, let's get printing. So literally we've done everything and we're to the point now where we can get in and start actually doing a, profile tuning, right? So this is where we would literally come into our orca slicer, things like that. And seam aligned. We're going to put that to classic. We're going to do inner, outer, inner. Save. And we'll come up here to calibrate. And I'm not even going to do a temperature test. How about that? I'm just going to go straight into doing this. We set our temperature to 220. Okay, so no, you were not the only one that couldn't hear. Nobody could hear because my batteries died on my mics, which means, yeah, we've been going for about 6 hours. Holy cow. So yeah, it's definitely a long night, but yeah. I really wanted to try and get this going. So yeah, this is going pretty good. So yeah, as I was trying to say is make sure that you do a first layer squish test first. Do not change your squish as you start this print, because remember the very first thing that it's trying to do is a 20% under extrusion. So if you go through and try and get the right squish for that, when it hits the 20% extra extrusion, it's going to be way over extruding, or not over extruding. It's going to have way too much squish, and you'll start running into issues. So there's that fan. We're going to kick that down some. When that fan ramps up, it gets to be like 75 decibels at a meter. And sorry, I'm trying to hold the camera and make sure you can see. And this is the stock 0.6 profile. I've just basically changed from Arachne to classic, inner, outer, inner on the walls, and 0.25 on the initial layer height. But beyond that, it's the standard 0.25 quality for a 0.6 nozzle. And yeah, it is alive. That is for sure. Yeah, so that part cooling fan is a 40-40-28. So it's a fan that you would see in many servers. So that is kind of loud. And darn it, I drop it and it keeps raising it back up. So Yes, this is doing the extrusion multiplier past 1. So this goes from -20 up to 20 in steps of 5, percentage of 5s. Oh yeah, Tracy Ev. I'm gonna have to go into the slicer and change it from a max of 100. Oh, thanks, Gulsifer. Yeah, it's just, that fan's way too loud. I don't have any, well, I have one panel on it, and I'm standing on the other side of it just to try and dull it down some. But, yeah. And this will be the last print tonight. My wife would kill me if I continue to run prints like this. Oh, not a problem, Gulsifer. Oh, very nice. Yeah, I've got my V01 sitting over here. It works perfectly fine. All I need to do is put a door back on it because I had to steal the door panel because I broke the one that was on Bubblegum Dragon for Free Heathen. So I had to scavenge my door panel to get it on there for them. But I have plans of breaking it down and rebuilding it as a V02. This printer right here, okay. Exactly, Gulsifer. Do it on stream as a forcing function. So Trace, were you talking about this printer right here? If so, this is a black box. This is a 5-head tool changer. Currently I've got tool head 0 is a standard, I'll say somewhat standard. It's a E3D V6 setup. So titanium heat break, nickel plated copper heat block with a 0.6 gamma nozzle from Slice Engineering. Then tool heads 1 through 3, whatever. The other 4 tool heads are E3D Revos with high flow heater cores and 0.6 obsidians. The issue I'm having is I think I'm having basically brownouts because I'm running the higher wattage heater cores on all 5 tool heads. So I think what I'm going to do is pull the LRS 350, put in 2 UHP 300s, and power each of the boards from one of the 300s, and that way I shouldn't have any potential power issues. Are they separate or stacked? So it's, if you've seen a Prusa XL, that's kind of what it is. So you've got 5 separate tool heads, and the gantry goes over and picks it up, one in order, or whatever order it needs to be. Ah, gotcha. So the issue is if the print needs 4 tool heads, it heats up all 4 tool heads at the same time, and it maintains them all at the printing temp because they sit on a silicone stopper, and then it's water cooled. So the active tool head is water cooled via a gantry cooling block, and then the idle tool heads are all water cooled via a common aluminum channel. So yeah, it's the issue of all the heaters hitting at the same time, and when it goes to do a rapid move to go over to do the bed mesh, it'll skip steps because I think there's not enough amperage for the motors when it does the rapid move. So it happens less if I'm trying to. Yeah, so my plan is to replace the LRS 350 with 2 UHP 350s, and one will power the main board, which is a Duet 36HC. One will power the secondary board, which is a Duet 33HC, and that is the heaters and thermistors for 3 of the tool heads. So that'll break it up. The advantage of water cooling is just minimizes the heat creep issue. So if you're not water cooling, every time you pick up or drop a tool head, you really need to drop the temp. So if you look at like the Micron or the 2.4 was the tap changer, stealth changer, whatever they're calling it. You have to have all 6 fans running to keep the hot ends cool and up to temp so you don't get heat creep. Right, so you've got all the hot end fans that are active, or all the hot ends that are active, their fans have to be running. And even then, I think you're probably better off, depending on material, dropping the temp down when the tool's not in use. I know Zombie will be able to tell you a little bit more about that because he's built the tap changer and had a tap changer and a Micron changer running at Rocky Mountain. But yeah, there you go, Mr. Wizix. And I had Black Box at Midwest Rip Rap Festival. And if you're going to 3D Printopia, I plan on bringing it there as well. And I'll have one, and KB3D will have his. And I'm not sure who else will bring theirs. I know Steve Builds will not be bringing his because he's not going to ship it. And I don't know if Turtle Crawler actually, or not Turtle Crawler, PID. I don't believe PID has his up and running yet. The pump and the radiator for the pump is running on a 12 volt. And so it's a step down, it's running at 12 volts. And it really doesn't pull that much. Overall, I don't know the energy efficiency between them. I'd have to really look at, try and get some real world numbers from like Zombie on his 6-head tap changer. and then I've got black box, so we can try and pull some real world numbers. Oh, thank God. Thank God. Hey, Creatix Brit, how's it going? Welcome on in. Okay, other than the fact that my square corner velocity still sucks, so it's rounding all the corners. Like I said, still need to do some tuning. This is still straight factory profile. One thing you do need to be careful of here is make sure that you get your nozzle clean, because this does do beacon contact, so it will, just like the Prusa Mark IV and XL, it does tap the bed with the nozzle. So I'll pop this off and okay. Sorry, I was taking a look at these. So here's what that print came out to look like. And looking at these, I believe I want to do the second pass at +5, because that'll go, it's basically going to run the middle range of +5 through -5, and 0 looks like there's a slight gap. I really think it's going to wind up being like maybe 1 or 2. And once again, I'm running this as a 0.6 hardened nozzle. And yeah, I really think when I do this next, I'll want to run it at, I'll go ahead and update it to by 5% positive, run the second pass, which will go from 5% positive to 5% negative. And somewhere in that round will be the one that I'll need. I'm gonna set this down here on my little tablet here. I'll have to run some more of these tomorrow. But the RatRig is alive, and we will be printing with her over the next several days. So get a K2 plastic scraper. You know what? I had one. I had the round one somewhere. I have no idea what I did with it. I'm gonna have to print a couple more because it just kind of grew legs and ran away. I have not thought of a name yet. Slab stations. Yeah, I've been going for a little over 6 hours. I cannot run any more prints because this thing is pretty loud and my wife will kill me. So yeah, I would use a thumbnail or something, but unfortunately I cut my nails not too long ago. So but yeah, with that, gang, yeah, I've been live for quite a while. I'm gonna try and bring, just kind of do this. This thing is so big that my main camera over there, I mean, if I go to the main camera, you can see me to the side of the printer, but you're not seeing me over the printer, basically. It's kind of big. Especially for a 300 size printer, it's pretty big. But I am very happy with this so far. Like I said, the fan's kind of loud. But I think between now and Thursday, I'm going to continue to do some tuning prints to try and get things tuned in so we can print something fun on Thursday. I'm also going to do a little bit of dress up. So we'll put the cable or the cable sleeving over the umbilical cables and stuff like that. Um, we'll go ahead and get the side panels done. Um, I mean, the side panel is really peel off the um, whatchamacallit, peel off the stickers, put a bunch of screws in, and then slap it on and rotate. So the sides aren't that big of a deal. The top and the door frame will have, you know, this does not have a door that opens. It has a panel that attaches with magnets. So that's an interesting thing there. Um, but yeah, all in all, it's a very nice printer so far. Um, there's plenty of room in this printer. I'll kind of walk everybody around it again on Thursday night. Um, and yeah, with that, gang, I am kind of tired. I need to head off to bed. My sleep pattern's been a mess this whole week. I know it's Tuesday. It feels like Friday. Um, yep. So let me see if we got a raid target, somebody that's still out there going, because I know it's kind of late. And Pride Nuda, Declarations, Tuner, Many Dragons, Crisperillo, Maker Deck, Astro Canucks up, Science. Anybody have a suggested raid target? Shall we go to? Thank you for sharing the build config process. Hey, not a problem, Mr. Wizix. Is Ratatouille rig? Oh, Gulsifer. Yeah, we'll have to think about a name for this one. We will have to figure out a name for this one. But yeah, I think we went to Science the other night. We haven't been into Astro Canuck in a little while. How does everybody feel about Astro Canuck? Ratatouille. Love them? Okay. Well, I'll go ahead and get it started for Astro Canuck. And folks, thank you all for being here. I'm sorry. Let me try and figure out which I'm going to do. Let me do this. There we go, because I can stand over on this side. Hey, folks, thank you all for being here. Thanks for coming along on this journey as we build this RatRig 300. There's going to be more content on this. Hey, Moto Freak, welcome on in for the first time chat. Hey, Winsing, how's it going? But yeah, thank you everybody for being here and for everybody that rated in and came out. I know it was a long stream today. We're going to keep playing with this printer and we'll probably print with it Thursday and maybe even some on Saturday. We'll see. But yeah, it's been a great build. It's been interesting because it's a little bit different than our Vorons. So that's always good. We're learning. But thank you everybody for being here. Show some love over to Astro Canuck. And oh yeah, definitely like the RatRig Techno Slide. And we will see you guys on Thursday night. All right. Bye now, everybody. Well, bye now, everybody.